In this video, we'll be working on 12-2 trigonometric functions of acute angles. So, from the triangle, the right triangle given to you, where one of the vertices is on the origin, we are going to label this coordinate x and that coordinate y. Therefore, this point has to be x, y, and we label this angle theta and label point P as x and y. So we learned that sine of theta is going to be opposite of theta, and over hypotenuse of theta, that's going to be x, and this value r, we can call that r. From here to here is supposed to be y, the height, so y over r. Using the same logic, cosine of theta is going to be x over r, and tangent of theta is going to be y over x. So using this, moving on to example 1, we're given the triangle that has 8 here, 6 here, and a point 8, 6, and theta. If you're looking for sine theta, then using Pythagorean theorem, this is going to be 6 squared plus 8 squared, square root of that, which is 10. So sine theta is going to be 6 over 10, which simplifies to 3 over 5. Cosine theta is going to be 4 over 5, and tangent theta is going to be 3 over 4. Knowing sine, cosine, and tangent, you can figure out the rest of the trig. So you also need cosecant theta, which is equal to 1 over sine theta. Then flipping this value, you get 5 over 3. Secant theta is going to be 4 over 5, or 5 over 4. And cotangent theta is going to be 4 over 3. So you can pause the video here and try the problems on the next page. Since there are 8 problems. And moving on to example 2, let's actually do one of the problems there together. Number 5, use cofunction identity. It says sine of phi, or phi, is equal to cosine 12 degree. And knowing sine theta, sine A, is equal to cosine B, if A plus B is equal to 90 degrees, and therefore phi plus 12 degrees should be 90 degrees, so phi is going to be 78 degrees. This is the answer to problem number 5. Problem number 8, cosecant phi is equal to secant 73 degrees. Knowing it's technically 1 over sine theta, or sine phi, is equal to 1 over cosine 73 degrees. Cross multiply both sides, you get cosine 73 degrees is equal to sine phi. So it's exactly the same problem. Phi has to be 17 degrees to make the sum 90. Example 2. Find sine theta and tangent theta if theta is an acute angle, and you're given cosine theta is equal to 1 over 2. So knowing cosine is equal to 1 over 2, you can first figure out sine squared theta plus cosine squared theta is equal to 1, which is always true. So this is going to be 1 over 4. So sine squared theta is going to be 3 over 4. Therefore sine theta is going to be 3 over 2 if you square root both sides, and tangent theta is equal to sine theta over cosine theta, which is rad 3 over 2 over 1 over 2. So rad 3 will be tangent theta. Then you can try numbers 9 through 13. Example 3. To find the lengths of side BC and side AB, use a table 558 of your textbook to find tangent 45. This I just highly recommend you to use calculators. So using calculator, tangent of 45 degrees is equal to 1 and cosine of 45 degrees is going to be 0.707. Or this is also equal to square root of 2 over 2. So using these, if you're given a triangle where this value is given as 8 and that angle is given as 45 degrees, let's label these as A and C. So sine of, or let's deal with tangent first. Tangent 45 degrees is equal to A over 8, which is 1, knowing 45 is equal to 1. So A has to be 8, and C can be solved using Pythagorean theorem. And if you have no questions with these, you can go move on to problems 14 through 19. So pause the video here and try the rest. 12-3, trigonometric functions of general angles. So general angles doesn't have to be now below 90 degrees. It can also be above 90 degrees. So one of the angle we're given is from a point 5, -5, -12, which is a point right there. Then from the origin, that's the terminal side that you can draw. So one of the rules from the trig is that the angle that forms is not only this, it's always going to be from the positive x side, and you have to make an angle starting here all the way up to where you end the terminal side. So you can tell this angle has to be greater than 180 degrees because it's greater than the straight angle. And it's then going to be the sum of 180 degrees here plus that angle theta right there from this triangle. Then from this, we can still figure out using Pythagorean theorem, -5 squared plus -12 squared, square root of that gives you 13. So the length from here to there is going to be 13. So redrawing the triangle that has -5, -12, and +13 means the hypotenuse will always be a positive value because square root of square numbers will always turn into a positive. So knowing this is the angle theta, sine of this angle theta is going to be opposite over hypotenuse. Cosine of angle will be -5 over 13. Tangent of angle is going to be -12 over -5, which turn into +12 over 5. And you can figure out cosecant, secant, and cotangent just simply inversing them. So try work on numbers 1 through 5. Example 2, reference angle. So reference angles are important when the angle formed is not in the first quadrant. So if your triangle has the angle in between 0 and 90, your triangle will be formed in the first quadrant, and that will be the reference angle, where if your angle is in between 90 degrees and 180 degrees, then it goes somewhere there. And this is going to be the triangle that you're supposed to form. So even though this is the data, your triangle should always have a leg on x-axis. So this is the angle that the triangle has. And this angle is the reference angle. And this applies to third quadrant as if this is the terminal side, and angle is in between 180 degrees and 270 degrees. So that is going to be the angle. This is going to be the reference angle because your triangle forms that way. And in fourth quadrant, terminal side, this is the angle by your triangle forms this way. So that's going to be the reference angle. So calculating the reference angle is pretty simple. Let's say this angle right here is 135 degrees. Then reference angle, that has to be 45 degrees because these two are supplement in that case. Let's say this angle is equal to 210 degrees. And knowing this is 180, that reference angle has to be 30 degrees. Let's say right here the angle is 330 degrees, and this reference angle has to be 30 degrees because it's a remaining portion from one revolution, and one revolution is 360 degrees or 2 pi. So knowing this, you can try numbers from 6 to 17, then example 3. Write 230 degrees as a function of acute angle. Now, sine of 230 degrees. So sine of 230 degrees is, so knowing 230 is greater than 180, that will be the angle right there that we label it as 230 degrees, but 230 is definitely not an acute angle. Then in order to be an acute angle, it has to be in between 0 and 90 degrees. So this is how the trick works. First of all, the reference angle is this angle right here, and the reference angle is going to be 50 degrees. So knowing sine of 50 degrees is somehow relevant to sine of 230 degrees, but the only difference from here to there is sine 230 degrees will give you the adjacent value that is negative, where 50 degrees gives you the adjacent that is positive. So you have to label it with a negative sign, then they are equal. So sine of 230 degrees can be written as negative sine of 50 degrees, and this 50 is an acute. So this is a trick that you shall draw to figure out, and all problems from 18 through 25 can be solved in this way. For now, to work on example 4, I recommend you to use a calculator at the moment only. We are going to deal with all the little bit of the memorization part in a bit. So I'll pause the video here. This was the work up to 12-3, and on next video I will work on 12-4 and 12-5.